Thank you, Hu. As Hu mentioned, sustainability is an important issue on this project. In order to address the means by which the goals could be accomplished, a 2-day kickoff eco-charrette was set in motion to identify further green goals that would go beyond the energy performance and cost reduction challenge implemented by Gerding Edlin Development. Beyond energy performance and a reduced cost for the mechanical system, the design team identified a desire to obtain 100% capture and reuse of rainwater on site, have a minimum of 50% reduction in potable water use, and also sought to provide substantial amounts of power and chilled water on site from a combined heating, cooling, and power plant. All sewage was also to be treated on site and reused for non-potable uses. Overall, the design team was quite successful at addressing these issues and focusing on these challenges. The building obtained a LEED Platinum rating and is often viewed as one of the most complex buildings in the country to achieve such a high standing. As far as design strategies and features are concerned, the Oregon Center for Health and Healing incorporates a number of design strategies and design features that have allowed it to perform at a high level and receive such a high LEED rating. With rainwater collection and reuse being such an important design strategy early on in the project's design phase, the project team has implemented a system in which the reclaimed rainwater and groundwater is circulated in concrete slabs for radiant cooling of the ground floor and main lobby area. To address air quality during the winter months, the team has employed a solar collector trom wall which occupies the 15th and 16th floors of the building. In this system, warm air is collected from the surface of the wall and is circulated through the building as a passive means to control interior building temperatures and to reduce energy use. Heat rejected from a micro-turbine central plant is harnessed and used in the building pool when there is excess heat. Electric lighting within the building is controlled by occupancy sensors in hallways and stairwells to ensure that it is used only when needed. The stairwells also incorporate passive heating, cooling, and natural ventilation to reduce energy costs. The chilled beam system that is used in the building allows for a smaller HVAC system when compared to a conventional forced air system. In many of the various programmatic spaces, the design team has placed occupancy sensors that control exhaust, lighting, and ventilation systems to ensure that the building performance is optimized. When dealing with a project of this complexity, taking an integrated design approach is an ideal means by which one can address solutions pertaining to climate, building use, and system selections. An integrated design process requires a highly collaborative method to achieve optimized results. From the start of the project, team members analyze climate data such as temperature, rainfall, groundwater, and wind flow data to evaluate and discuss climate loads, passive design strategies, and to focus on possible integrated design strategies. Programmatically, this building is extremely diverse. With such a broad range of programmatic spaces, it is important to evaluate each based on temperature, lighting, and ventilation comfort criteria that would be required for each occupancy type. This allowed the design team to adjust their design assumptions accordingly to relax temperature ranges in certain areas and reduce lighting levels for other spaces. Due largely to an integrated design strategy and some green initiatives that have been employed in the project, the building's energy use is nearly 60% less than conventional buildings of this type. Potable water use is also reduced by 54%, which is more than the design team had originally designed for. Sustainable design features increased the project cost by more than $1.8 million. However, the project has received more than $1.2 million in tax credits and incentives, and although the project costs an additional $600,000 to obtain LEED Platinum, the building saves $500,000 in energy costs per year. The OHSU Center is the first large-scale building in the U.S. to replace air conditioning with chilled beams placed horizontally just beneath the ceilings. In this system, chilled beam water passes through the beams and natural convection currents carry cool air down to the occupant level. This system manages to cut energy use by 20 to 30% and reduces the need for ductwork. This building also uses a stormwater and sewage treatment plant on site. Rainwater and groundwater collection is treated and used for irrigation, urinal flushing, and is used in the cooling tower. 100% of wastewater is treated on site with a membrane bioreactor. Eco-roofs and the use of bioswales contribute to more than 50% reduction in stormwater runoff. The membrane bioreactor is a wastewater treatment system that uses membrane cartridges instead of gravity as a barrier to separate the effluent from the biomass or remaining sludge material. Once treated, the effluent can then be used as gray water for toilet flushing. The bioreactor treats over 15,000 gallons of waste and sends only 400 gallons to the sewer. In addition, the building uses 5 60-kilowatt natural gas microturbines located in the central plant that serves the building. Nearly one-third of the electricity used by the building is generated from the combined heat and power turbines. In addition to these factors, the project incorporates numerous other design strategies to obtain a LEED Platinum certification. I will now hand the presentation over to Cameron, who will talk a little more about some of these design strategies.